to the foundation. Or if it is a roof or floor loads, lateral loads applies on roof, on floors, and any other boundary elements. So shear wall, the function of shear wall is to transfer the lateral loads to the foundation. The shear wall is given to be used in a building. It must have its own and efficient strength and stiffness. Also, we can say that a shear wall must be perfect and must be useful while we are persisting that to coincide both the center of the mass and the hardness. Then a shear wall can be most effective, and it can prevent more, and it can support and resist more lateral loads. So, to have a shear wall, this is used that a sway force can be resisted by a shear wall. And also, a straight external, we can say a shear wall is a straight external, typically a box shape, which is RCC, that is a shear wall. And also, we can say a RCC truss, or vertical truss, a shear wall is that. And to resist the horizontal forces, we have several types of shear walls in a building usage. So one of them is, for sometimes we design and consider a shear wall for a moment resisting. We have the figure for a moment resisting shear wall. A stiff and flexible shear wall is a most stiff and flexible shear wall, which is already considered in the middle of the building to resist. Here they have proved that to coincide both the mass, the center of the mass and the hardness of the building or shear wall, to coincide both of them, it can resist more lateral forces. A monolithic shear wall is another kind of shear wall that we have considered that this is a shear wall which can be defined as a ratio between the depth and the height of that. So if the depth is between 1 and 3, if the ratio between depth and height is less than 1, it is a short shear wall. If it is between 1 and 3, it is a squid shear wall. If it is greater than 3, then it is a cantilever shear wall. It can be designed the same as a cantilever beam. Plan, flange, and channel, there are other shape of shear walls which are used in a building. They are in different usages, whatever the requirements. So we are going to use the shear walls. A couple shear wall, sometimes we have in a building design, we have some windows, doors, some other holes in a building that we are required. So we are going to use some holes on that shear wall. Therefore, we use a couple shear wall. It can join beams and slabs. The usage of shear wall, it can be used in two types. A shear wall according to their boundary. I told you that shear wall must be considered in with the boundary conditions, with the boundary elements or surface elements. So in these cases, shear wall can be used in two cases. One, it is with elements with increase of thickness. The elements which are used inside of shear wall, if it is within the increase of thickness of that, so that is one shape. The other one, the other usage is without the thickness. It means shear wall thickness must be less. The boundary elements thickness is more. And also one more thing, that shear wall maximum and minimum, it is 150 mm to 40 mm, the thickness of shear wall. In this case, according to ICE code, the shear wall, we can resist the seismic loads. For resisting the seismic load, shear wall is the best retrofitting. And also the radial distance from the center of the mass and of the structure. Features should be constant while analyzing and designing. While designing a shear wall, those elements that we are needed are loads. For example, we consider some loads. What are the loads? External loads, imposed loads, dead loads, seismic load, live, and these loads are we can consider. And also the dimension, external and internal dimension. Materials, what are the materials, and previous experimental data for comparing. That what are the results in previously, what are they now. So a shear wall, you can also say it is a retrofit of a seismic. A shear wall, when we design, it is a retrofit of a seismic load. And also A low mass of a shear wall gives a good ductility and strength. And also, we can say that a shear wall must have an energy dissipation. It can transfer
your time.
So, okay, sir. So, for conclusion, we can say a good steel mixture, shear wall, and will give us a toughness and stiffness and strength, durability, and stability. Also, for a high seismic performance, high-rise load shear walls can be used. Conclusion: we have the deformation capacity of a shear wall increases as per ratio of horizontal reinforced panels, and also the compressive hedging region and the shear wall boundary columns are used in the boundary columns. Thank you very much.
If you go to the conclusion slides. What is that compressive boundary of panels?
The compressive hinging region is to be
Like first point only.
okay. Use shear wall